So now that we understand frequency distributions, we're ready to turn those into graphs. So the first type of graph that we want to study is called a histogram. And this is vertical bars whose heights represent the frequency, or it could be relative frequency. Really important is there's going to be no space in between these bars, and that each bar needs to be of equal width. Also, as you're drawing the graphs, be sure that you label your axes with titles. Notice we've got frequency and class listed on the X and Y axis, if you think of that below. And also, you want to be sure to start each class at the class boundary, and that's actually shown by this example to the right. So what happens is, instead of looking at the table on the left where there's a gap between 6 and 7, I'm going to work with the table on the right, where my first class goes from 3.5 to 6.5. So what I want to do is, starting at 3.5 at the bottom of the graph, draw a line straight up to a frequency of 2. Now I'm going to come across until I'm above my upper boundary limit. So I draw across till I'm at 6.5 and then go down to 6.5. So now I need to go from 6.5 to 9.5. And as I look at my graph, I notice a slight problem. I really should have had 9.5 instead of 9.6. But starting from over here at a height of 1 on 6.5, I'm going to come across and down into 9.5. And for my last vertical bar in my histogram, I'm going to be coming up from 9.5 and going across down to 12.5. So this is the graph we're looking at. Be careful of the graph on the left. When I go to draw the first bar, I'm going from 4 to 6, and so I just have this vertical bar off to the left. Then for my next class, which is 7 to 9, it's as if there's a gap, and only 7 to 9 has a height of 1, and only 10 to 12 has a height of 3. So what happens is, on the left, this is not a histogram. It's not clear that the data is continuous, and so that's why I want to count the graph on the right. So here's an example all together. So I'm given the directions to create both a frequency and a relative frequency histogram. Now don't forget, with a histogram, the first thing you have to do is be using the boundaries, and since I don't have those boundaries, remember, I'm going to take 15 minus 14 to get 1, divide that by 2 to get 0.5, and from here, I'm going to be subtracting 0.5 from all the lower limits and adding 0.5 to all the upper limits. And I have my boundaries, my frequencies given to me, and my relative frequencies given to me, so I don't have to calculate any of that. So first thing I want to do is draw the frequency distribution. So I kind of start by making this L shape, list my class boundaries across the bottom. My highest frequency is a 6. So I'm going to a height of 6 across the top, labeling my y-axis and my x-axis, and now I'm ready to go ahead and draw the graph, where, remember, I'm kind of drawing straight up out of the boundaries and connecting from there. And I've got my first graph drawn. Now for the relative frequency, like I said, they're already created. The graph starts to look similar. I've got the boundaries across the bottom, but on the y-axis, remember, I'm going to have relative frequencies where the highest frequency is 50%. I decided to go by 10 percentage points here. I've labeled my axes and I'm ready to draw the graph, of which I go a little bit faster, or sorry, not faster, but show you some of the parts where once I've got my first bar, you know, I'm going to come across and down, and in this case you don't even see the third bar, and so I have to come up across and down for the last bar. And now you have the completed work. In Chapter 3, we'll talk a little bit about shapes of distributions, and in Chapter 6 and on, we're going to be extremely interested in what's called a bell-shaped distribution. And here's a histogram kind of showing you that. And the reason it's called a bell shape is it has this general curve. Because we have bars, it's not a smooth curve, but just an example of a histogram that's going to play an important role later on.